Welcome to the channel, everyone. Today I'm going to demonstrate how to troubleshoot a broken AC system. I'll start off by saying you should always hire a licensed professional. These units have extreme electrical currents that run through them, and they can be very dangerous to work on. So I got home from vacation yesterday, and my house was about 90 degrees. My AC would not turn on, and I tried all of your basic troubleshooting steps, from flipping the circuit breaker to reset the system, checking the thermostat to make sure it was working properly, and checking the lines to make sure they weren't frozen up. Everything looked great until I came outside and saw the fan wasn't spinning on the outdoor unit here, and the compressor would not turn on. All I could hear was a slight humming sound coming from the unit, and I'll play a quick clip so that you can hear that for yourself. Hopefully you could hear the faint humming sound coming from the unit, as well as the short, loud burst hum that the unit generated when it was trying to start up. So I'll quickly walk around to the back of the unit, and this is where we're going to start our troubleshooting. We're going to remove these 3 screws here and 2 screws on the side to get into the access panel, and you'll see some components in here. I'll talk a little bit about the most common culprit for this unit to fail, and then we'll hopefully get it fixed. So I've removed the access panel, and before you do anything, make sure that you cut the power at the circuit breaker. Then once the panel is removed, you may want to take your multimeter and test the contact points to make sure there's no power coming through. So I'm going to focus on the capacitor. This is a very common culprit when your AC dies, and I can see here already my capacitor is starting to bulge at the top. That means it's probably gone bad. I still want to be very careful even after cutting the power, because these capacitors hold anywhere from 370 to 440 volts. The first thing I'm going to do is remove each of the wires after I write down what they're connected to. So I have the blue connected to the Herm, red connected to the common, and brown connected to the fan. Make sure you notate which wires go where. It's very important. So I'm going to use some insulated pliers. They have rubber grips, and I'm going to go ahead and pull these wires out. And I have one screw holding in the capacitor. So I'm going to go ahead and remove that. The last thing I'm going to do is pull the capacitor out. I'm not going to touch any of the terminals. I'm going to put my hand in through the back here and just push it out, and then grab it by the sides. Now I know this one is not holding a voltage because I've already checked that, but still you want to be very careful and handle it as if it is holding a voltage. So now that I've pulled it out, we're going to go ahead inside and test it with the multimeter. I'll show you how that's done. We'll order a new one, and I'll show you how to install the new one. We're now ready to test our capacitor to see if it's functioning properly. First, I'm going to share some important information with you. This particular capacitor is a dual run, which means it's really 2 capacitors in one and supplies power to both the compressor and to the fan. Some systems will have 2 separate capacitors, one for the fan and one for the compressor, but it really just depends on your system and your particular setup. Since this is a dual run capacitor, we have 3 terminals, and they should all be labeled. This terminal is labeled C, which stands for common, Herm, which stands for hermetically sealed compressor, and fan, which is for the fan. You also want to look at the specifications on the label. This one is 35 microfarads plus 3 microfarads and 440 volts. The 35 is for the compressor and the 3 is for the fan. So when we test this, those are the values we'll be looking for. Now we're ready to test our capacitor. So I'm going to go ahead and turn on my multimeter. And I've put it on the capacitance setting. And I'm going to take my black lead and connect it to the common terminal, and my red lead and connect it to the Herm terminal. And you'll see I'm not getting a reading. That means the Herm terminal is bad. Now we'll test the fan. And we're not getting a reading there either. So I think it's safe to say this capacitor is defective. I'm going to go ahead and order a new one. And when it comes in, I'll show you how to test the new one. My house remains extremely hot, but luckily my new capacitor arrived today in under 24 hours. I placed the order yesterday around 3 p.m. through Grainger.com. They had it to me today at noon via UPS next day air. So props to Grainger for great service and really quick shipping. I'm going to quickly go over some specifications to look for when you're ordering a replacement capacitor. And the most important ones are making sure the microfarads match and that the voltage is compatible. I'll quickly zoom in and you'll see on my old one, it was 35 microfarads and 3 microfarads with 440 volts. The new one, microfarads match, 35 plus 3 and 440 volts or 370 volts. It's important to note that when you're looking at the voltage, you can go over but not under. So if you have a 370 volt capacitor, you can install a 440 and it should be okay. But if you have a 440, you don't want to go below that. The other thing to look for are the dimensions of the capacitor. And what I mean by that is looking at like the diameter and the height and making sure it fits in the mounting spot on your AC unit. My old capacitor was about 5 inches tall and it had a diameter, which is the most important thing for my unit, of 2.5 inches. The diameter is just right across the center of the circle. My new capacitor matches in diameter. It's 2.5 inches, but it's a little bit shorter, which is fine for my system. It should mount and fit perfectly. So I'll quickly show you how to test it using your multimeter. And I'll quickly get set up for that. All right, so I'm gonna go ahead and turn on my multimeter. And we're gonna put it on the microfarad setting. I'm going to take my black lead and plug it into the COM port, and my red will go in this far right port. Then I'll take the black lead and connect it to the common terminal, which is indicated by a C, and my red one, and I'm going to connect it to the Herm terminal. And you'll see nothing happens on the old capacitor. Then I'll do the same with the fan. And I don't get a reading. Now we'll test the new capacitor to make sure that it's reading around 35 microfarads and 3 microfarads. So I'm going to connect to the common with the black and then to the Herm with the red. 34.34 microfarads. So that's within range. It's plus or minus 5%. That looks good. Now we'll do common and fan. It should be right around 3. 2.975, perfect. So my new capacitor looks good. Next, I'm gonna go outside, install it, and hopefully my unit turns on. All right, so we're ready to install the new capacitor. And basically it's going to be the exact reverse of what you did taking the old capacitor out. Make sure your power is cut at the circuit breaker, which it should already be. Then you're just going to slide it in. I'm going to go ahead and secure the mounting bracket. I'm testing it to make sure it's secure. Looks good. Now I'm going to reconnect the wires. And if you recall, when I removed the old one, blue goes into the Herm terminal. Brown is the fan. And red is the common. All right. Now that we're all connected, I'm going to turn on the AC and it should be fully functional. Let's see what happens. Now I'm going to turn on the AC. You can see it's 87 degrees right now, so wish me luck. Now we're going to go outside and see if it's on. All right, here it is. My unit is running again. You can see the fan spinning. I can hear the compressor running. My diagnostic test was correct. The new capacitor has fixed the issue. This capacitor cost about 20 bucks and I paid $40 for overnight shipping for a total of $60 to repair my AC. Had I hired a technician, it probably would have cost about $300 to have this repair done. So I saved quite a bit. But again, this is dangerous work. You're working with electricity. Be very careful. And I always recommend that you hire a qualified HVAC mechanic to do this work for safety reasons. So you should not do it yourself. Thanks everyone for watching and good luck.